The United States just quietly banned a metal in EV manufacturing that China produces 68% of globally. And if you don't understand what that means, you're about to watch the entire Western electric vehicle industry collapse in real time. This isn't about better batteries or cheaper labor. This is about a supply chain stranglehold that makes OPEC look like amateurs. China controls the materials, owns the processing facilities, and just triggered a restriction that will force every automaker in America and Europe to either pay triple or shut down production lines. And 2026 is when the consequences hit full force. Let me explain what actually happened because the mainstream automotive media completely missed this. In late 2024, China implemented export restrictions on antimony and several rare earth processing technologies. Antimony is a critical flame retardant used in EV battery casings and electrical components. But buried in those same restrictions was language around silver processing and rare earth extraction methods that use silver compounds. Most analysts focused on the antimony angle. Almost nobody noticed the silver language. That was the real weapon. Silver is used in every single electric vehicle, not as a minor component, but as a critical material in electrical contacts, battery management systems, and power electronics. The average EV uses approximately 25 to 50 grams of silver, depending on the model. That doesn't sound like much until you realize global EV production is projected to hit 30 million units in 2026. That's 750 to 1,500 tons of silver demand just from EVs, and that's on top of existing demand from solar panels, consumer electronics, and industrial applications. Total global silver production is only around 25,000 tons annually. And here's the problem. China doesn't produce the most silver, but they control the refining and processing infrastructure that turns raw silver into the high-purity industrial-grade material EV manufacturers need. Approximately 40% of global silver refining capacity is in China. But more importantly, nearly 60% of the specialized silver compounds and alloys used in electrical contacts and conductive pastes are manufactured in Chinese facilities. When those export restrictions kicked in, they didn't ban silver exports outright. That would be too obvious. Instead, they restricted certain processing methods and required lengthy approval processes for exports of specific silver compounds classified as strategic materials. The result is the same. Western automakers now face supply constraints and price increases for a material they absolutely cannot build EVs without. And this is where most people don't connect the dots. Why would China do this now? Because they've spent the last 15 years building a completely vertically integrated EV supply chain that doesn't depend on Western suppliers for anything critical. Chinese EV manufacturers source their silver domestically or from processing facilities in countries where China has direct investment and partnership agreements. BYD, Geely, NIO, XPeng, they're not scrambling for silver supplies. They have guaranteed access. Meanwhile, Tesla, Ford, GM, Volkswagen, Mercedes, BMW, they all rely on global commodity markets and just-in-time supply chains that are now disrupted. Let's talk about what this looks like in practice. In January 2025, the price of industrial-grade silver for electrical applications jumped 23% in a single month. Not because of silver scarcity overall, but because of processing bottlenecks and export approval delays. By March, lead times for certain silver-based conductive pastes used in battery management systems extended from 6 weeks to 18 weeks. That doesn't just increase costs, it disrupts entire production schedules. If you can't get the silver components for your battery management system, you can't complete the vehicle. So you either halt production, which costs money, or you redesign components to use less silver, or substitute materials, which takes months of testing and regulatory approval. Western automakers tried the redesign route. Ford and GM both announced initiatives to reduce silver content in their EV electrical systems. Tesla claimed they could reduce silver usage by 30% through design optimization. But here's the reality. You cannot eliminate silver from high-current electrical contacts in EVs. The material properties of silver, specifically its electrical conductivity and resistance to oxidation, are unmatched by any practical alternative at scale. Copper is cheaper, but oxidizes and has higher resistance. Gold is better, but costs 10 times as much. Graphene-based materials are experimental and not ready for mass production. Silver is the only material that delivers the performance EV electrical systems require at a cost that makes mass-market EVs financially viable. So while Western brands scramble to reduce silver usage by 20 or 30% through engineering compromises, Chinese manufacturers are building EVs with optimal silver usage and absorbing zero supply chain disruption. The performance gap might seem small on paper, but it shows up in real-world reliability, charging efficiency, and warranty claims. An EV with under-spec electrical contacts might work fine for the first year, but after 80,000 kilometers and hundreds of fast charging cycles, those contacts degrade faster. Resistance increases, heat builds up, components fail early, warranty costs skyrocket. And this brings us to 2026 specifically. Why is that year the tipping point? Because that's when the second wave of mass-market EVs from Western brands is supposed to launch. Ford's next-generation electric F-150, GM's Silverado EV hitting volume production, Volkswagen's ID.7 and ID.8 models for the US market, Stellantis finally launching competitive EVs after years of delays. All of these programs were designed and validated assuming normal silver supply chains and pricing. They locked in their bills of materials 18 to 24 months ago when silver was 30% cheaper and lead times were predictable. Now those programs are launching into a market where their material costs are higher than projected, their supply chains are fragile, and they're competing against Chinese brands that have none of those problems. The BYD Seagull launches in international markets in 2026 at a starting price around $11,000 with decent range and features. The Xpeng G6 arrives in Europe at €35,000, undercutting the Model Y by €8,000. The Geely Galaxy E5 enters developing markets at prices Western brands cannot match. And all of them have stable silver supply chains because they're sourced domestically or through Chinese-controlled processing facilities. But it goes deeper than just silver. Silver restrictions are just one piece of a larger strategy. China also controls processing for lithium, cobalt, graphite, and rare earth elements used in motors. Approximately 80% of global lithium refining happens in China, around 70% of cobalt refining, nearly 100% of natural graphite processing for anodes, and over 90% of rare earth separation and processing. Western countries have lithium mines, cobalt mines, rare earth deposits, but they don't have the processing infrastructure. So the raw materials get shipped to China, processed, and sold back as battery-grade materials at a markup. This is the stranglehold. It's not that the materials don't exist outside China, it's that the industrial infrastructure to turn raw materials into usable EV components is concentrated in China. And that infrastructure took 15 years and hundreds of billions in government subsidies to build. Western governments are now trying to build domestic processing facilities, but those won't reach meaningful scale until 2028 or 2029. The Inflation Reduction Act in the US and similar programs in Europe provide subsidies for domestic battery and material processing. But you can't build a lithium hydroxide processing plant or rare earth separation facility in 2 years. It takes 4 to 6 years from permitting to full production, so there's a gap. The gap is 2026 and 2027. During those years, Western automakers will be caught between rising material costs, supply chain instability, and aggressive competition from Chinese brands that have none of those constraints. And the market share numbers are already moving. In Europe, Chinese EV brands held 8% market share in 2023. That jumped to 11% in 2024. Analysts project 16 to 18% by end of 2026. In Southeast Asia, Chinese brands already dominate with over 60% of EV sales. In South America, they're rapidly gaining ground. Even in the United States, where tariffs currently make Chinese EVs uncompetitive, there's political pressure to reduce trade barriers as consumers demand cheaper options. And here's what makes this truly dangerous for Western automakers. Once market share shifts, it's nearly impossible to win it back. Brand perception matters. If consumers buy a Chinese EV in 2026 because it's cheaper and it works reliably for 3 years, they're not switching back to a Ford or Volkswagen EV in 2029 just because the supply chain stabilized. They've already formed their opinion. The Chinese brand delivered value and reliability. Why pay more for a Western badge? This is exactly what happened with Japanese cars in the 1970s and 1980s. American automakers dismissed Toyota and Honda as cheap imports with inferior quality. Then the oil crisis hit. Consumers bought Japanese cars out of necessity because they were fuel efficient and affordable, and those consumers discovered the quality was actually excellent. Reliability was better than American brands. Resale value held strong. By the 1990s, Toyota and Honda were considered premium, reliable brands, and American manufacturers spent decades trying to rebuild their reputation. That same pattern is playing out right now with Chinese EVs. The difference is the speed. The Japanese took 20 years to build global market share. Chinese EV brands are doing it in 5 years because the transition to electric is happening so fast. Legacy automakers can't gradually adapt. They're being forced to compete in a market where the rules changed overnight, and their supply chains weren't ready. And the silver restrictions are just accelerating a process that was already underway. Let's look at specific examples. BYD sold 3 million vehicles in 2024, up from 1.8 million in 2023. They're projecting 4.5 million in 2025 and targeting 6 million by 2026. Those are not small numbers. That's Toyota scale production. And BYD isn't just selling in China anymore. They're in Thailand, Brazil, Israel, Norway, Sweden, and expanding across Southeast Asia and South America. They're building factories in Hungary and Mexico. They're partnering with local dealers in dozens of countries. This is a global brand now, not a domestic Chinese manufacturer. Geely, which owns Volvo and Polestar, sold 2.8 million vehicles in 2024 across all brands. Their EV sales grew 87% year over year. XPeng, NIO, Li Auto, these are brands most Americans haven't heard of, but they're delivering hundreds of thousands of vehicles annually with technology that matches or exceeds Tesla in many areas. The XPeng G9 has better autonomous driving hardware than a Tesla Model Y. The NIO ET7 has a longer range and faster charging than a Mercedes EQS. The Li Auto L9 has interior refinement that rivals a BMW X7. These aren't cheap knockoffs, these are legitimate premium vehicles. And they're all insulated from the silver restrictions and material supply disruptions affecting Western brands. Because the entire supply chain, from mining to processing to component manufacturing to final assembly, is either in China or controlled by Chinese companies. That vertical integration is the competitive advantage that tariffs and trade restrictions can't eliminate. You can put a 25% tariff on a Chinese EV, but that just makes it less affordable. It doesn't fix the fact that Western automakers are paying more for materials and dealing with supply chain instability. Now, some people will say, well, Western governments will subsidize domestic EV production and protect local manufacturers, and they're trying. The Inflation Reduction Act provides tax credits for EVs with domestic content. Europe is implementing carbon border adjustments that penalize imports from countries with high emissions, but these measures take years to have an effect. And in the meantime, market share is shifting. The other argument is that consumers in Western markets won't buy Chinese cars because of quality concerns or geopolitical tensions. That argument falls apart when you look at consumer behavior. If a Chinese EV costs $12,000, less than an equivalent Western model, has similar features, and comes with a decent warranty, most consumers will buy it. Brand loyalty exists, but it has limits. If the price gap is $5,000, some consumers pay extra for the familiar brand. If the gap is $15,000, brand loyalty evaporates. We're already seeing this in Europe. MG, which is owned by Chinese automaker SAIC, became one of the top 10 best-selling car brands in the UK in 2024. The MG4 Electric outsold the Volkswagen ID3 despite being a relatively unknown Chinese brand. Why? Because it was 6,000 euros cheaper, with comparable range and features. Consumers don't care about geopolitics when they're looking at their monthly payment. And 2026 is when this dynamic goes into overdrive, because that's when Chinese brands launch their second-generation international models, the ones designed specifically for Western markets, with better software, better dealer networks, and aggressive pricing. The BYD Seal and Dolphin already launched in Europe and are selling well. The XPeng G6 arrives in spring 2026. The Zeekr 001 is coming. NIO is expanding their battery swap network across Europe. These aren't tentative market entries. These are full-scale invasions backed by billions in investment, and Western automakers are not ready. Ford delayed their next-generation EV platform. GM is scaling back EV spending after losing billions on Cruise and Ultium battery problems. Stellantis is years behind, with no competitive mass-market EVs. Volkswagen is profitable in China, but losing ground in Europe and has no US EV strategy beyond the ID.4. Mercedes and BMW are trying to compete in the luxury EV segment, but they're getting squeezed from below by Chinese brands offering 80% of the features at 60% of the price. Tesla is the only Western brand that's somewhat insulated because they built their own supply chain and have scale. But even Tesla is feeling pressure. Their market share in China dropped from 10% to 6% as domestic brands took over. Their European sales are flat, their growth is slowing, and they're facing the same material cost pressures as everyone else. They just have more margin to absorb it. So what does this mean for consumers? If you're in the market for an EV in 2026, you're going to have more Chinese options than ever before, and they're going to be aggressively priced. If you're loyal to Western brands, you're going to pay a premium. And that premium is partly because of supply chain costs driven by material restrictions. And if you're hoping Western governments will protect domestic automakers, they'll try. But market forces are stronger than policy. The dominance isn't guaranteed, but the trajectory is clear. China spent 15 years building a vertically integrated EV supply chain. They control material processing. They subsidize domestic manufacturers. They built massive scale. And now they're using strategic export restrictions to make life difficult for competitors while their own brands expand globally. The silver restrictions are just one tool in a larger strategy. It's economic warfare disguised as industrial policy, and the timing is perfect from China's perspective. The global EV transition is accelerating. Governments are mandating EV adoption. Consumers are finally ready to buy. And right at the moment when Western automakers need stable supply chains to scale production, those supply chains are disrupted. It's not an accident. It's strategy. And 2026 is when the effects become undeniable. So there it is. The reason China will dominate the electric car market in 2026 isn't because because they build better cars, though they're getting very good at it. It's because they control the materials, the processing, and the supply chains that make EVs possible. Western automakers are competing with one hand tied behind their backs. And by the time domestic processing infrastructure comes online in 2028 or 2029, the market share battle will already be over. The question isn't if Chinese brands dominate. The question is how much market share they take and whether Western brands can survive the transition.